Hello everyone. Good evening, all of you. Good evening. So in this session we are going to discuss about multiplication of vector. Yesterday we have so first we will recall the topic which we had learned yesterday, which we have learned yesterday. So yesterday I taught you about the addition of vector and as well as the types of addition. In that we have seen three types of addition vector we have discussed yesterday, and we have learned about the properties of vector addition and rotation of vector as well as resolution of vector and direction of cosine of vector, subtraction of vector. But now in this video we are going to discuss, in this live session we are going to discuss and learn and explore the knowledge about multiplication of vector. So first we will discuss here multiplication of vector. First, in that real by a real number, multiplication of a vector by a real number. When a vector a is multiplied by a real number n, then its magnitude becomes n times, but direction and unit remains unchanged. Now here it is written, when we are going to do the multiplication of a vector by a real number, what are the real number? We na 1 2 3 4 5 and 0.1 to 1.2 1.5 1.8, these all are the real numbers, yes or not? So when we are doing the multiplication, suppose we have a vector a, so when we will do the multiplication vector a with the 2, then the new vector we will get, that new vector is 2a vector, 2a vector, but magnitude of this vector is 2, magnitude of this vector is 2. So here when we will do the multiplication with the real number, multiplication of vector by a real number, then we will get the new vector. What we will get? We will get the new vector. Suppose we are doing the multiplication vector a to a into 5. So we will get the new vector 5 vector a. So it will, if we will solve it, then if we will change it, then we can write also mod vector 5a equal to, what we will get? We will get vector 5a. Now if we will do the multiplication with the negative numbers with the so what we will get? We will get minus, suppose we are doing the multiplication minus 2 with the vector a. So what we will get? We will get the new vector, that is the minus 2a vector. And here if you see, the magnitude is similar, but the direction is changing here, because my minus sign shows that the direction of vector. So here it is written, if we are doing the multiplication of any real number, then the magnitude becomes n time, but the direction and units remains unchanged. But when we will do the multiplication with the negative, so then we will get the magnitude similar, magnitude will never change, but what is the different here? The direction will change. Now next one, by a scalar. So in a by a scalar, when a vector a is multiplied by a scalar s, then its magnitude becomes s time, and unit is the product of unit of a, vector a and s, but direction remains same as that of vector a. So when we will do the multiplication. What is the scalar? A scalar magnitude, a scalar, we know that a scalar, those physical quantities have only what? Only magnitude. That is known as a scalar quantities. So here if we will do the multiplication with the 2 I cap plus 3 j cap, so k we will consider as a k we will consider as so here we can write, suppose for example we are taking 2 I cap plus 3 j cap. So what we will write here, we can write here, so for that we will consider k equal to minus 2, so we will do the multiplication with the 2 cap 2 minus 2 cap I minus 2 plus 2 3 cap j minus 2, then the new magnitude will, new vector we will get, and in this vector the direction will never change, as well as the magnitude will change, but the direction will not change. Now next one, which topics, the next topics we have, a scalar are dot products of two vectors. A scalar are dot product of two vectors. In that, so the scalar product of two vector is equal to the product of their magnitude. So in here a scalar vector, what is a scalar? We know that a scalar have only magnitude. So when we are doing the product with a scalar quantities, then two vector is equal to the product of their magnitude. So suppose we are taking vector b and vector a, and when we are doing the dot product with two vector with the scalar quantities, then their magnitude and the cosine of the smaller angle between them, it is denoted by dot. Now here two vector, and between vector a and vector b one angle is creating, that angle is theta. So here we are writing a dot b equal to a b cos theta. It is a dot product of a scalar quantities. Now properties of a scalar product. Now a scalar product is a commutative, that is a dot b equal to b dot a. A scalar product is a distributive. It means a dot b plus c equal to a dot b plus a dot c. A scalar product of two perpendicular vector is 0. So when we are doing the when we are finding the product and two scalar product of two perpendicular vector, it always becomes 0. So for that we are writing a dot b equal to a b cos 90 degree equal to 0. Now next point, a scalar product of two parallel vectors or anti-parallel vector is equal to the product of their magnitude, that is a dot b equal to a b cos 0 degree, where cos 0 degree equal to what we will write. So here a b for parallel, and a dot b equal to a b sin 180 degree. So it will becomes -1. So minus a b we will get. Here cos 0 degree 1. So a b for parallel, here dot a b equal to a b cos 180 degrees. So it will becomes -1. So for anti-parallel we will write, because here the direction is changing. Here the direction is same. When the angle between vector a and vector b, and that angle is 0, cos 0, then the parallel, both we are getting a b as a parallel, and magnitude as well as the direction is not changing here. But when we are doing the product between vector a and vector b, then we are getting AB cos 180 degree. The angle is creating between both vector, and so here the direction is changing. So here magnitude is similar, but the direction is different. So that's why it is written here anti-parallel. Now next one, a scalar product of a vector with itself is equal to the square of its magnitude. So here a dot a equal to a into a cos 0 degree, it will becomes a vector square. A scalar product of orthogonal units vector cap I equal to j dot cap j equal to cap k dot cap k. So these all are the, so when we are doing dot product between the I cap, j cap and k cap, then we are getting 1. And when we are doing the multiplication dot product in a scalar, so from I cap to j cap, I cap dot j cap equal to j cap dot k cap equal to k cap dot I cap, then we will get the product 0. The scalar product in a Cartesian coordinate. We know that there are 4 Cartesian plane. In the Cartesian plane are Cartesian coordinates. So 4 coordinates we know that, yes or not? So according to that, if you do the multiplication, if you do the dot product between a scalar quantities in Cartesian coordinates, so a vector a dot vector b equal to a base x I cap plus a base y j cap plus a base z plus into k cap. Dot product b base x I cap plus b base y into j cap plus b base z into k cap. So it will becomes a base x into b base x plus a base y plus into b base y plus a base z plus b into b base z. Now next, which we have, vector are cross product of two vectors. So the vector product of two vector is equal to the product of their magnitude and the sign of the smaller angle between them. It is denoted by cross. So vector A cross B. Now before here we had studied about the dot product between two vector in a scalar quantities. Now we are going to discuss the cross product for the vector quantities. So here we are doing the cross product in the vector quantities, but we are doing the dot product in a scalar quantities. Why a scalar quantities? Because scalar quantities only magnitude is present, but the vector quantities magnitude as well as the direction will present. That's why we are doing the cross product in the vector quantities, two vector quantities. Suppose we have a vector and b vector, so we will do the cross product in vector A and vector B, then we will get AB sin theta n cap. So through this diagram we can see here vector A and vector B, between vector A and vector B one angle is creating, that angle is theta. That angle is theta. Now properties of vector we will discuss. Properties of vector product. Now vector is not a cumulative. Now a scalar, in the scalar product of two product we have seen. In the scalar dot product of two vector we have seen, what we have seen first, properties of a scalar product we have seen, that are the commutative, but vector product is not a commutative. It means when we will do the cross, when we will go to find the cross product between one vector to another vector, then it is not equal to b cross to a. in the scalar, what we have seen, what we have studied is when we are doing the multiplication dot product, we are doing dot product between a scalar, one a scalar vector and another scalar vector, then we are getting, and that is a commutative nature. What we are writing there, vector a dot vector b equal to b vector dot a vector, yes or not? But here in the properties of vector product, it is not like that, it is not a commutative natures. So that's why we can write here a vector a cross vector b is not equal to vector b cross vector a. Now, so since next there so vector, second point, vector product is a distributive. Yes, vector product is distributive, and also a scalar product also is a distributive. So a cross b plus c equal to a cross b plus a cross c. Vector product of two parallel vector is 0. When we will do the, when we are going to find the product between two vector quantities, then a cross b equal to, it becomes, then we will get the product a cross b equal to what product we will get, we will get the product a into b sine 0 degree, and it will becomes 0. So when we are doing the product, when we are doing the when we are going to find the product between vector a cross vector b, then we are getting the 0 product, we are getting the 0 product. Next point, point number 4, vector product of any vector with itself is 0. Whatever the vector, suppose vector a into vector a cross vector a, so when we are going to find the product between vector a to vector cross vector a, then product we are getting a into a sine 0 degree, and it's become 0. So the product of a cross a becomes 0. Now next one, vector product of orthogonal unit vectors I cap cross I cap equal to j cap cross j cap equal to k cap cross k cap, it becomes 0. Now here I cap cross j cap equal to minus j cap into j cap cross I cap, that becomes k cap. So now when we are going to find the product between j cap cross k cap, then k cap becomes minus k cap cross j cap, then we will get the cap I. Now if we are going to find the product between k cap cross I cap, then I cap becomes minus I cap cross k cap, then we will get the product j cap. So when we are going to find the product between I cross I cap, then we will get the 0 product. When we are going to do the cross product between j cap into j cap, then we will also get the product as a 0. When we are going to do the cross product between k cap and k cap, then we will get the product as a 0. But when we are going to do the product, when we are going to find the product between I cap and j cap, then we are getting k cap product. What we are getting? We are getting the product k cap. When we are doing the cross product, when we are going to find the cross product between j cap and k cap, then k cap becomes minus, and we are getting the product, final product we are getting I cap. And when we are going to find the cross product between k cap and I cap, then the final product we are getting j cap. Now here you can see the I cap and k cap in the circle. So this is a becomes a plus, and this is a becomes minus, because here the magnitude is a clockwise but direction is clockwise. That's why the plus is written here. The direction is anti-clockwise. That's why it is written minus. Now next one, vector product in Cartesian coordinates. So in the Cartesian coordinate mode, we are using the mode. So when we are going to find the cross product between a vector and b vector, then we are writing a base x I cap plus a base y j cap plus a base z k cap into b base x I cap plus b base y j cap plus b base z k cap. So for that we are writing vector I, vector j and vector k. So for that we are writing mode, we are in the mode we are writing vector I a x, a base x and b base x, vector j cap j a base y and b base y, vector k a base z and vector b base z. So we will get, if we will do the multiplication, if you want to find the product between cross product between j cap and k cap, cross product, if you want to find the cross product between j cap and k cap, then j cap we will write a base y and b base z. Cross multiplication, cross product we are doing here, we are going to find the cross product. So we will do the multiplication a base y and into b base z. So we are doing the cross, we are going to find the cross product between j cap and k cap. We are not going to find the product cross product between I cap and j cap. So that's why we will not write a base x into b base y. We will not write this. When we are going to do the find the cross product between I cap and k cap, then we will write a base x into b base z. Yes or not? Are you getting? I hope. So here we are going to find the cross product between j cap and k cap. So that's why here we are writing, here is it is written a base y and b base z minus b a base z and b base y. Now, and it is a I into I cap minus a x. Now what we are going to find? We are going to find the cross product between I cap and k cap. So I cap and k cap. So here we will write a base x and b base z minus b base x and a base z into j cap, and plus what we are going to find now next one. So next we are going to find the k cap. So we will do the cross product between j between I cap and j cap. So between I cap and j cap, so a base x into b base y minus a base y into b base x. So here into k cap. Now next one, next, and this is the last topic for today in this video, in this live session, division of vector by a scalar. So this is the second last. Now next one, direction of vector cross product. When c equal to a cross b, the direction of c is at a right angle to the plane containing the vector a and b. The direction is determined by the right hand screw rules and right hand thumb rules. So we have studied in the class 10 in electricity chapter right hand rules. Yes or not? Right hand thumbs rules. Right hand thumbs rules. So on the base of right hand thumbs rule, we will find the direction of vector cross product. So here we are going to find the vector cross product between vector a cross b. So here two vector a and vector b, then angle is creating theta. So we are using the right hand thumb rules. So in the thumb, this vector is telling about the magnitude, direction, telling about the direction. Now right hand screw rules, rotate a right hands screw from first vector A, then towards second vector. Suppose this is a two vector, so first vector this one and second vector this one, this vector A and this vector A. So for this we will use and we will curl the finger. Yes or not? We will curl the finger. Now then B, vector B, the direction in which the right hand screw moves gives the direction of vector C. So in which direction it moving, so it will give the direction for vector C. Now next one, right hand thumb rules, curl the finger. Right hand thumb rules tells about the curl the, when we are curling, suppose this is a vector, so when we are doing the curl of the finger, so curl of a right hand finger from vector A to vector B, then the direction of the erect thumb will point in the direction of A vector B. Yes or not? So now here the next point we have division of vector by a scalars. The division of vector A by a non-zero a scalar m is defined as the multiplication of vector A by 1 upon m. In this, the unit of resultant vector is the division of unit A and m. So here in the division vector by a scalar, so we have studied in the scalar and vector quantities. So this chapter is over today in this live session. So in the second chapter we had discussed and learned about the scalar and vector quantities. First we had discussed and learned about the scalar, then we have learned about the tensor, then vector quantities. Then after I taught you about the types of vector, two types of vector. One is a polar vector, another is axial vector, and other types of vector we have discussed, like a equal vector, zero vector, negative vector, yes or not, a null vector, unit vector, orthogonal vector, co-initial vector, co-linear vector, localized vector, non-localized vector. We have discussed positive vector as well as a displacement vector. And also I taught you the second part video in this, the second chapter, second part video, I taught you about the addition of vector and subtraction of vector. And today we have learned about the multiplication of vector and division of vector by a scalar quantities. Yes or not? So in the multiplication of vector we had discussed about the cross product and dot product. Where we are using the cross product, we are using the cross product in vector quantities, and we are using the dot product in scalar quantities. A scalar are dot product of two vector we have seen and we have studied in that. Today we have learned about the scalar are dot product of two vectors, and we have learned vector are cross product of two variables. So when we have a scalar quantities, so in the scalar quantities, if you want to find the product of any two vector, then we have to use the dot product. But if you want to find the product of any two vector by the cross product two vector, then we have to use the cross product. And cross product not a commutative nature, but a scalar is a commutative nature. Yes or not? So this one we have learned, and we have studied about properties of vector product and properties of a scalar product. Yes or not? And finally we had learned and discussed about the right hand thumbs rules and division of vector by a scalar. In the division of vector by a scalar, the vector a by a non-zero scalar m is defined as the multiplication. So when we are going to find the product between using the division of vector, then what we have to do? Here we are writing a vector by 1 upon m. M is a multiplication. So that's all about today. We will discuss next chapter tomorrow in the live session. So keep watching, keep learning, keep subscribing, and keep sharing. Have a nice day. Bye bye.